Good morning, chemistry students, and welcome back to Single Displacement or Single Replacement Week. I hope you're finding this week to be tremendously exciting, one of the best weeks we've had this entire school year. But we finished the week off today with the Single Displacement and Single Replacement Lab. It is a 2-day lab, so take your time on it, do some of it today. You can finish it up tomorrow. Maybe today you'll get through just the single displacement activity series of metals part, and that's the first portion of the lab, and we'll be discussing that right now. The first video you're going to watch on the activity series part of the lab, activity series of the metals, will be just an informational video telling you how it works, what to look for in the reactions, and what is happening. You'll want to stop the video at this part right here, where there will be a little bit of information about what is actually taking place during the reactions, and then you'll resume with the information. At the end of page 2, the information portion of the lab is over, the background information is over, and we're getting ready to start the lab. So when you click on this link in Google Classroom, this is the actual beginning of the lab. Be sure before you begin the lab that you take the time to read the laboratory report. One of the big things that you're going to look at there at that point is, what is this table? In this lab, we're going to be dropping metals. These are the metals that you'll be placing in solution. So all these metals will be placed in a container, and these solutions will be squirted into or on top of the metals, and you'll be looking to see if a reaction happens. If you note, these are the ions listed, the positive ions, the cations listed that are in the solution. The reason that is the only thing listed and not the entire solution, the negative ion, the anion is not on there, is because when we have a metal reacting with an aqueous solution of a salt, it's the metal reacting with the positive ion. So there's no need to list the negative ion, because the negative ion, as you remember, is the spectator. It doesn't do anything. So what they're going to do then is, in the very first reaction, they're going to drop these pieces of metal into containers, and then they're going to put hydrochloric acid, I believe, on those metals, and they're going to watch to see if a reaction happens. If the metal reacts with the solution, that means that that metal is displacing the positive ion that is in the solution. So right here, if the acid reacted with the metal, you would write RXN. If it doesn't react with the metal, you would write NR. If the magnesium metal reacted with the solution, you would write RXN. If it doesn't react, you would write NR for no reaction. So the very first series of reactions, you're going to be reacting these metals with the hydrochloric solution. In the second set, you're going to be reacting these same metals with zinc sulfate solution. And we're going to continue on and on and on. You're not actually going to write your results on this table. This is just an informational table. Your actual table that you'll write your results on are right here. Notice some of the boxes have NR in them. This is the actual table you'll be writing on. The reason that is there is you would not, if you're going to have copper and you're going to be putting in a copper solution, copper metal will not react with its own ion. So NR is already filled out on that table for you. In the same way, magnesium would not react with magnesium ions. Tin would not react with tin ions. So that's why there's some NRs already written on the table for you. Here's the actual reactions that are taking place. On here, they tell you the solutions they are really in. So the zinc is in the zinc sulfate solution. The copper is in a copper sulfate solution, but the sulfate ions in both of those are spectator ions, so they don't get involved in the reactions. When you're watching these reactions, they will do some up-close shots of them. But understand, the thing you're looking for is the metal that was dropped in there changing colors? Is the solution overall changing colors? Are you looking for a bubbling, formation of bubbles? If you see those kind of things, you know that a reaction's happening. If you see fizzing, you know that reaction's happening. Some of them are very difficult to interpret. So at the end of the lab, before you actually start your conclusion in lab write-up, I will post tomorrow a table which gives what should have happened so that you can compare what you saw to what should have happened. And that will help you when you get to your data and calculation section of the lab, which is right here. So what you'll do is, if you saw a reaction happen over here on the table, if you see a reaction happen, you will write the balanced equation for it. If you did not see a reaction happen, you would write NR, no reaction. So if magnesium reacts with the hydrochloric acid, you would know that a chemical reaction happened, obviously, and then you'll write the balanced reaction. If you saw a reaction happen, you would know that the magnesium is more active than the hydrogen ions that were floating around. In this first one, if you dropped copper in hydrochloric acid, or you had a piece of copper metal and you squirt hydrochloric acid on it and no reaction happens, you would write NR. What would we know from that? That hydrogen's more active than the copper. So you'll go through. The first two are done for you in terms of what you're doing here. None of the equations are balanced for you, so you'll need to balance all the ones where a reaction happened. If a reaction doesn't happen, you would just write NR. And then you'll fill out the remaining things. So if tin reacted with the hydrochloric acid, you would know that SN is more active than H. After you have this table filled out, there are a set of conclusions that are made for you already. See if you can understand how they got these conclusions. You'll do the same thing for the set of reactions too. If no reaction happened, you write an NR there. If no reaction happened in any of these other ones, you would write an NR there. And then you would decide which is more active. If the metal reacts with the solution, the metal's more active than the metal that was in solution. If no reaction happens, then the metal that was in solution is more active than the metal that was reacted with the solution. Again, these conclusions are already made for you. And that is how we'll do the activity series for you. The big thing is to see if you understand how they were able to interpret the conclusions that were made. This continues on to this page as well. And then the final activity series that could be derived from those reactions is listed there. That would be a good one. This first part of the lab, the activity series of the metal, would be a good one to do today. The activity series of the halogens, if you have time today, you could get to that. It's not that long of a video, but if you want to wait and do that tomorrow, that's fine as well. But they're going to actually determine the activity series of the halogens. And that is on this page right here. And then the final page of the lab involves just taking a look at some awesome, fun to watch single displacement or single replacement reactions. I hope you enjoy the lab. When you are finished with this lab, I just need for you to take some pictures to show me that you completed the lab and the various pages of it, and share those with me to my email. Have a great end to our single displacement and replacement reaction week. Monday, a reminder, we will be doing an assessment to see what you took away from this week. Have a great day, have a great lab, and enjoy your weekend. Thank you.